Hi everyone, and I think it's necessary to talk a little bit more about joint probability for discrete random variables. When you have x and y, two discrete random variable, and how to find out the joint probability of these two random variables. Um, Many times it's kind of tricky, and as you already seen in the problem one in the class note, and also you probably will see being confused by the homework problem. So let's spend a little bit more time and go through a couple more examples. Then you can uh, you know hope it will be helpful to your homework. Okay. All right. The tricky part is x and y, they are not independent. Okay. So if they are independent, then computing the jump probability basically will be the product of two marginal probability. So problem will be solved. But it's not they are not independent. That means we have to figure out the context of the problem, and from the context of the problem, and figure out what kind of distribution can be used there. Okay, um, let me switch to my document can. All right, here you have this example, okay, and we discussed in the class, okay. Um, no, it says there's 100 pages, and we are going to sample 4 pages out of 100 pages, and those pages 60% has low graphic content, and 30% has moderate graphic content, and 10% has high graphic content. All right, and X is the number of pages has moderate graphic content, and Y is number of pages has high graphic content. All right, so it asks you to fill out this table. As we said before, it's the contingency table. Okay, X and Y. Okay, and X could be 0, 1, 2, 3, 4 because the number of pages, right? So in the samples, there are totally 4 pages. So X could be 0 to 4 and same to Y. All right. And because X and Y, they are not independent. Okay. Um, X and Y basically are two properties to the page. Okay. To a web page. Okay. And moderate content, graphic contents and high graphic contents. Um, they are not uh, uh, totally independent to each other because they come from the same page. Okay, um, that's why over here many cells has 0 because you cannot have 4 pages all have moderate graphic contents and also have high graphic contents. Okay, that's impossible. All right, so many of those cells are 0. Okay, and in the class, we discussed, why this is a hypergeometric case. All right, um, that's because there's a finite population, 100 pages, and the sample taken from this finite population, 4 pages taken from this 100 pages population. All right, and the result of the first selection obviously will affecting the result of the next selection. All right, so that's why the hypergeometric distribution will be used here. Okay, and basically it's the combination case. Okay, as we discussed before, find out the probability from combination. Okay. And here we have actually three categories. Okay, not two categories, but three categories, right? So so for this cell, it means x equal to 0, y equal to 0. So there's no pages, has moderate graphic contents, and no pages has um, high graphic contents, for those four pages, right? So that means all four pages will have only low graphic contents, right? If you look at here, x equal to 1 and y equal to 0, what does it mean? One pages has moderate graphic contents, and the 0 pages have high graphic contents. So one pages has moderate graphic contents, then the remaining three pages will have only low graphic contents, right? Okay, so figure out the meaning, through the context of the problem. X equal to 2, that means two pages has moderate graphic contents, and y equal to 0, that means the remaining two pages will have only low graphic contents, and so on. All right. So let's see how to find out the probability. You know, as we said before, bivariate x and y, uh, discrete random variables, right? And if they are independent, okay, then the joint probability basically will be the product of marginal probability. Okay, but if they are not independent, okay, and you need to figure out what's x equal to x, y equal to y, what's the meaning of this combination, okay, in the problem context. All right. Um, we call it contingency table, right? And for discrete bivariate, okay, um, on this table, you will find that many cells will be 0, and for other cells, okay, uh, binomial distribution and hypergeometric distribution typically are very important, okay, and in our problem one, okay, the hypergeometric distribution is important. And there's another problem in uh, problem two, right? This problem we also discussed in the class. This problem, the uh, binomial distribution, is very important. Okay, and again, um, whether or not it's binomial or hypergeometric depends on uh, whether or not this p could be a constant. All depends on your first selection, the result of the first selection uh, will affecting the result of the second selection and so on. Okay, uh, if the result of the first selection will not affect a subsequent selection, then that's binomial. And if uh, the result of the first selection or the previous selection affecting the subsequent selection, then you should consider hypergeometric case. Okay, all right. Um, let's go back to this problem. All right. Um, let's say in the class, we talk about x equal to 0, y equal to 0, right? And let's look at another case, x equal to 1 and y equal to 0. Okay, x equal to 1 and y equal to 0. What's the probability? Okay, x equal to 1 and y equal to 0. So what's x equal to 1, y equal to 0 means? It means one moderate, okay, one page has moderate graphic content, and y equal to 0, so there's no page has uh, high graphic contents, then that means the remaining three pages, right, all have low graphic content. All right, so x equal to 1 and y equal to 0 means in those four pages, one page has moderate graphic content and the three pages has low graphic content, right? So how could they be? I mean, three pages has low graphic content and one page has moderate graphic content. How many combinations there could have? Okay, it could be M L L L and L M L L L L M L and L L L N, right? So um, so those combination could be okay. You could have those combinations, but um, how are we going to figure out the probability for each combination? Now, again, think about there's an urn, right? And there's 100 ball, and 10 of them are high. You mark high, and 30 you mark moderate, and remaining 60 you mark low. This case, MLLM, okay, means the first selection is a M. So what's the probability of you take, a M ball from this urn? That's 30 out of 100, right? Now, the second is L. How many how many balls remain in this urn? 99, right? Because one has been taken out, so 99 remain in the ball in the urn, and this selection is an L. So the chance must be 60 out of 99, right? And same, the third ball, okay, the chance is 59 because, right now already one L ball has been taken out, so remaining is 59. 59 out of 98, 98 because you already have two balls, taken out from the urn, so the remaining total is 98, right? And last one, still an L ball. Okay, an elbow remaining is 58. 58 elbows remaining in the urn, and the total number of balls remaining in the urn is 97. So it's 58 out of 97. Okay, and time them together, that will be the probability of this combination, right? But we have several other combinations. Okay, and you can do the same calculation, the same reasoning here, do the calculation, and we need to add all those combinations together, right? So there's four of them. Okay, but if you look at the number here, basically for each case, okay, they will have the same value, okay, same probability value, okay, and that's because the numerator is always 30 times 60 and 59, 58, right? And the denominator will be always 100, 99, 98, and 97. Okay, although the sequence could be different, but their probability value will be the same. So you just need to calculate one and then times four, right? Okay. Um, Now, let's see another case. X equal to 0 and y equal to 1. What does that mean? Y equal to 1, that means there's one high graphic content, and x equal to 0, there's no moderate graphic content. So there will be one page has high graphic contents and three pages has low graphic contents, right? Again, you can list that, all the combination here, right? And do the same calculation, and you just need to calculate these probability ones and times four, okay? Now, you think about, y is four, okay? Um, it's basically is the combination four choose one, okay? We have four boards and only one board is high graphic content, right? Only one board is high board. Okay, so it's four choose one. Okay, that's why this value, this probability value need to times four. Okay. Um, one more example, okay? And x equal to 1 and y equal to 1, okay? And what does that mean? X equal to 1 and y equal to 1. Okay. Um, one moderate, one high, and remaining two will be two lows, right? Okay. Um, so it should be easy to figure out this probability value. Okay, one moderate come from this moderate 30, and the one high come from those 10 balls high, and two lows, okay, they all come from this part, 60 low ball. And if you choose one, and then that will be 60 out of the population, and the next one will be only 59 out of the population, so that's 60 times 59. And again, denominator will be from 100 times 99, 90, 98, and 97. All right. But the tricky part is how do I find, how many combinations there are? Okay. And if you list them, okay, and eventually you will find there's 12 combinations. All right. If you draw the picture here, and what I need to do is to list, LL, low, low, okay. There's no others of LL, right? So I only to need to to show out how this low ball distribute, okay, over here. Okay, so that will be LL, but for the other two plays, okay, for these other two plays, it could be either N, H, O, H, L, right? Okay, and now I can move this L, the second L, to the third place. Okay, so LL, and again, NH, fill out the other two places, and HL, right? And again, I move one L to the last place, okay, and that will be HM and NH, and so on. Okay, and now I move the first L to the second place, okay, and H, H, do it again, move the second L to the last place, and finally all LL they are in the last two places. Okay, so if you count how many combinations there are 12. Okay, but is there other ways, without explicitly counting, how many combinations? There are any other way to get this number 12? Okay, well, you think about, LL, how I place low low into those places in those four location. Okay, that's four location, choose two, right? Four, choose two. Okay, I can place LL. Okay, so four, choose two. But after four, choose two, place LL. How many ways I can put M and H to remaining locations? Okay, or we can always do M, H, or H, M. Okay, so either MH or HM. So there's two ways, to place M and H. Okay, so time them together, 4 choose 2 times 2 equal to 12. Okay, that's how I figure out how many combinations there. Without doing all the our drawing here, you know, explicitly, show, all those combination. You but anyway, you can see that, it could be tricky. And again, come back to our earn model and the combination, we talked about in previous class. Okay, and I hope this video can be helpful to you understand this problem, and also maybe the problem in your homework. All right.